Hi there. We're going to have a look at simplifying surds. In order to do that, we need to be aware of our square numbers. I've listed the square numbers from 1 to 12 at the top of the screen. These will be vitally important in today's lesson. So if you don't know the square numbers, now is the time to pause the video, go away and learn them off by heart. For example, we need to know that 4 squared is 16. We need to know that 9 times 9, 9 squared is 81, and so on. Okay, if I was to start with 3 questions and I asked you to simplify the following, we've got the square root of 36, the square root of 4, and the square root of 7. If we look at simplifying the first one, the square root of 36, what number squared gives me 36? So that would give me a solution of 6. What number squared gives me 4? Therefore, the square root of 4 is 2. This is when the problem arises though, because 7 is not in our square number list. So if we try to take the square root of 7, we do not end up with a whole number. We do not end up with an integer. So if we go to take the square root of 7, the simplest form we can present it in is actually leaving it as the square root of 7. This is what we call a surd. So this is what we are looking at in today's lesson. On the next few slides, I'll go on to define that a little bit more. Okay, so first of all, we need to think, what does it mean to give an exact answer? In maths, we're often asked to round our answer to 2 decimal places, or 3 significant figures, or the nearest whole number. But as soon as we do that, we're losing some accuracy in our answer. As soon as we round our answer, the accuracy is reduced. And that's why surds become helpful. Because if we can leave an answer in a surd form, we can be sure that that is an exact answer. There's no rounding inaccuracy. Okay, so from the first slide, the square root of 7, if we put that into the calculator, would give us 2.645751 and so on, which we could round to 3 significant figures. As soon as we round it and get this answer, we have lost the accuracy of what root 7 actually is. We've lost this bit of the decimal, and of course that continues further than the 1 0 I've included on the screen. So what is a surd? A surd is a square root which cannot be reduced to a whole number. So square root of 7 would be a surd. Square root of 3 would be a surd. Any square root sign which has a number underneath it that cannot be reduced to a whole number. A surd is an irrational number. So we're looking up here at the irrational sense of this number. The digits after the decimal point do not get repeated. They do not produce a pattern. So we refer to it as an irrational number. A surd is a number that cannot be expressed as a fraction involving 2 integers. So if we think of the fraction 2/3, that would give us 0.66666 recurring. So it would have sort of a repeated pattern in the digits after the decimal point. Therefore, it could be expressed as a fraction. It would not be surd. Okay, so we're going to start off with a couple of examples. So we're going to start off by simplifying surds. So just like when we simplify fractions or we simplify algebra in maths, when we simplify a surd, we want to present it in the simplest way possible. When we're talking about a surd, the smaller the number under the root sign, the simpler the surd may be. Okay. So I've got root 18 here, square root of 18, or I could say root 18. In order to simplify it, I'm going to split it into 2 factors, 2 numbers which multiply together to give me 18. Notice how they're both still square rooted. One of those factors has to be a square number. Okay, that's how we're going to simplify the surd. So if I'd split this into 3 and 6, that wouldn't really be helpful because neither 3 or 6 are a square number. Because 9 is a square number, we can go ahead and simplify that to take us to 3 root 2. The square root of 9 simplifies down to the integer 3. So notice that we started the question with an 18 under the root sign, and we finished the question with a 2 under the root sign. Therefore, we have simplified the surd. Let's try another example. Root 75. So I want to simplify this surd. Okay, I'm going to split it into 2 factors, one of which needs to be a square number. Okay, so 25 times 3 gives me 75. Both are still square rooted at this point, and 25 is a square number, which is excellent because it means I can simplify on the next line, and I'm going to make root 25 simplify down to the integer 5. That's going to leave me as 5 root 3. So 5 root 3 is the simplified version of root 75. Root 48, we can split that into 2 factors, root 16 and root 3. You may be looking at that and thinking we could split it into root 4 and root 16, with 4 being the square number. However, in order to get the smallest number under the square root sign, we want to remove the highest possible square factor, which is why I've chose the 16. 16 times 3 gives me 48. 16 is my square number, which simplifies down to 4 root 3. I started with a 48 under the root sign. I ended up with a 3 under the root sign. So this is my simplified surd. Okay, here's 2 for you to do. If you pause the video, work out the simplified version of each surd. Okay, welcome back. I'll just show you my solutions. There we go. So for 12, we have split it into root 4 and root 3, and the 4 has simplified down to the 2 here. Over here, we split it into 25 and 6, and the root 25 has simplified down to the 5. 2 more for you to do. Again, could you pause the video, have a go at simplifying these surds, and then I'll show you my solution. Okay, welcome back. My 2 solutions look like so. So if I just focus on the last question here, I've split it into 49 and 3. Root 49, 49 being the square number, that simplifies down to 7. 7 root 3. I started with 147 under the root sign. I finished with a 3 under the root sign, so I've simplified my surd. Okay, again, pause the video, see if you can come up with some ideas. Why do mathematicians like working with surds? Okay, welcome back. If you pause the video, here's a few ideas. It preserves accuracy throughout the calculation. So if we're working with a surd and we don't round it or start dealing with a decimal, we're just keeping everything a lot more accurate. It allows us to give an exact answer, which is more accurate than rounding our final answer. If we present our answer as a surd, we're dealing with an exact value. If we keep it as a surd, we may be able to cancel it later in the calculation. If it gets squared later in the calculation, then obviously it's going to be quite straightforward to square a square root because they're opposite functions. Okay, so now if we look at adding and subtracting a couple of surds. So the first thing to be aware of is that We cannot add or subtract surds if the number under the square root sign is different. We need to make sure the number under the square root sign is the same before we add or subtract the surd. So what I'm going to do is I'm going to simplify root 48. At the same time, I'm going to simplify root 27. So I've split that into 16 and 3, 16 being the square number. I've split that into 9 and 3, 9 being the square number. When I go ahead and simplify that, I now have a 3 under the square root sign and a 3 under this square root sign. Now it's a straightforward addition. 4 root 3 plus 3 root 3, we treat it like algebra. So if that said 4x plus 3x, we would know that the answer is 7x. So we treat it as algebra. 4 root 3's add 3 root 3's is going to give me 7 root 3's. Okay, let's go ahead and have a go at a subtract question. I've got root 98 minus root 72. Differing numbers under the root sign. Therefore, I can't go ahead and just subtract. I need to simplify each surd first. So I'm going to split root 98 into root 49 and root 2, and I'm going to split root 72 into root 36 and root 2. 49 being the square number here, 36 being the square number here. They both simplify down. 7 root 2 and 6 root 2. Therefore, I can go ahead and do the subtract. Again, treating it like algebra, 7 root 2's take away 6 root 2's is going to leave me with 1 root 2, or I could just say root 2. It's probably worth mentioning that at the top of the screen of my last few slides, I've been talking about irrational numbers. Make sure we understand why that is, because a surd, when presented as a decimal, it would have an infinite number of non-recurring digits after the decimal point. Therefore, it would be an irrational number. So every time we're dealing with a surd, you can assume it is an irrational number. Okay, your turn to have a go at a few questions. Remember, here you have the ability to pause the video. So please go ahead, pause the video and calculate the following surds. Welcome back if you paused the video. If we look at the first one, for 4 root 2, we don't actually need to simplify. We already have 4 root 2 in its simplest form. 2 is a prime number, suggesting that this is already in its simplest form. But we can simplify the root 32. We can split that into root 16 and root 2, and the root 16 would simplify down to 4. Now I've got the same number under the root sign. 4 root 2, add 4 root 2, it's going to give me 8 root 2's. For the second question, we'd need to simplify both the surds, simplifying root 500, splitting it into root 100 and root 5, which would simplify down here, and root 20 would simplify into, split into root 4 times root 5, which is simplified down here. Then we can go ahead and add them together. For our last question, we would split root 242 into root 121 times root 2, which would simplify down here, the square root of 121 being 11, and then root 50 would simplify down here, and then because it's a subtract, 11 root 2's take away 5 root 2's gives us 6 root 2's. Okay, let's have a look at a couple more sort of rules to do with surds. Okay, the first one being this rule here. If we have a surd and we multiply it by another surd, we can combine the numbers underneath the square root signs by multiplying them together. For example, root 2 times root 7 is exactly equivalent to the square root of 2 times 7, which is root 14. So you can see here that we've combined the surds together using this little rule up here. Root 8 times root 6 is exactly equivalent to the square root of 8 times 6, which would give me root 48. I could even go ahead and simplify this root 48 using the process we already know, splitting it into root 16 and root 3, 16 being the square number, simplifying it down to 4 root 3. Okay, we'll have a little look at this rule of surds, which is telling us that when we have a surd and we divide it by another surd, that is equal to the square root of the first number under the square root sign divided by the second number under the square root sign. Let's look at a few examples. Root 30 divided by root 6 is exactly the same as the square root of 30 over 6. 30 divided by 6, of course, being 5. So the simplified version of this is root 5. So I'll look at another one here. Root 60 divided by root 5 is equal to the square root of 60 over 5. 60 divided by 5 being 12. So the simplified version would be root 12. Again, we could go ahead and use the process we're familiar with to simplify root 12 by taking out root 4, which is the square number, simplifying down to 2. 2 root 3. So just two more rules of surds and simplifying surds we need to be aware of. Okay, a couple of exam questions here. If you would like to pause the video and have a go at each exam question. Okay, welcome back. In question 1, it asks you to express the square root of 98 in the form a root b, where a and b are integers and a is greater than 1. All of this sentence here is just giving you extra context, extra information that we may not necessarily need. All this question is asking us to do is simplify root 98. We know it's going to end up in this form, and we know a and b are going to be integers, and we know they're going to be greater than 1. So simplifying this is all the question's asking us to do. Again, down here, it's asking us to express our answer in the form a root b, where a and b are integers. Integers, if we don't already know, just means whole numbers. So if we go ahead and solve this using the method we're familiar with, our answer's going to look like this anyway. So don't let this sentence and this wording put you off. My two solutions look like this. So you can see I've split root 98 into 49 and 2 here, and the root 49 is simplified down to a 7. That's in the correct notation that the question wanted, but it was always going to end up in that order, in that notation anyway. You can see for question 2, I've shown you my working out with the solution being 10 root 3. So A is 10, B is 3. Okay, two more exam questions for you. Could you pause the video at this point and have a go at answering question 3 and 4? Okay, welcome back. My solutions look like so. So just have a little look through your notation, your working out. Check it against my working out. If you've got any corrections to make, please make sure you make those corrections. Okay, next task. Again, you have the ability to pause the video at any time. For each of these boxes, could you simplify down to a single surd and find the odd one out? So 3 of these answers are going to be the same. 1 of the answers is going to be slightly different making it the odd one out. Okay, welcome back. If you pause the video, and my solution to this task looks like that. The first, second, and fourth box all simplify down to 2 root 2's using various processes we've looked at in this video. If there's anything there confusing you, rewind the video, go have a look through my examples, go have a look through the previous questions until you have a good grasp of simplifying surds. This box here is the odd one out because it leaves you with an answer of 2 root 6. Okay, so I've also included a super challenge question here. I'm not going to talk you through the answer. I will show you my solution after you've paused the video, but without any information from me, I want you to have a go and see how would you find the area of this triangle, giving your answer as an exact answer, that is as a surd, but also rounding it to 3 significant figures. Could you pause the video and have a go at this challenge question? Okay, welcome back. My worked solution for this question looks like so. We know the area of a triangle is half base times height. We're going to use that, but we're going to input the surds for the base and the height. When we do a multiplication, it's as if we are expanding the double brackets. So 3 times 1 is where this 3 comes from. 3 times root 3 is where this comes from. Root 3 times 1 is where this root 3 comes from. Root 3 times root 3 is the same as root 3 squared. So the square root and the square would cancel out, leaving you with 3. Once we simplify that together, we end up with 6 plus 4 root 3. But remember, that still needs to be multiplied by a half because of the half in the formula at the beginning of the question, which we can then apply by expanding a single bracket to give us our answer as a surd. We could present it like this, with the 3 at the front, or the positive 3 after the surd. Either answer is correct. If we put this into our calculator and changed it into a decimal, this would be our answer, remembering this carries on indefinitely, which we could also round to 3 significant figures. 2 answers. This is an exact answer, so we could say this answer is more accurate than the rounded answer. Okay, hopefully you now have a good idea of simplifying surds, how to manipulate surds, how to simplify them into their simplest form, and also how to answer some exam questions involving surds.